we are not going to use the CRP site, so we are going to do these experiments in zero glucose. So with zero glucose, we don't have to worry about the CRP site. On Wednesday, we talked about a special kind of a mutant called constitutive. Constitutive means always on. And we talked about those kinds of mutations that would give the phenotype of constitutive mutant. And we saw an I- mutation and an O- mutation, that because this is negatively regulated, if we kill the I gene in any way, then we can never turn off the lac operon. Similarly, if we kill the operator so that the lac repressor cannot bind, again, without the operator, this is always on. So the two main constitutive mutants are I- and O-. I told you that Jacob and Monod won the Nobel Prize for figuring out basically everything we did on Wednesday in the lac operon. And the way they did it was by making heterozygotes. So E. coli normally has a single copy, but they used a trick that we talked about way back at the beginning of the semester in bacterial genetics for making partial diploids. Remember that you can use an F factor and get bacterial DNA segments on that F factor. So we're going to look at that. An F factor with the bacterial gene is called an F prime. And so they made an F factor with the entire operon from E. coli. So F, P, I, P, O. We're just going to look at Z. We're going to take it apart a little bit, and we're going to make a heterozygote, P-I, P-O, Z. So with this F factor, we now can conjugate this into any sort of mutation to ask a very simple question: what is the phenotype of the heterozygote? So let's start off, we have I first, and we'll put this plasmid into an I- mutant. So we now have the genotype I plus I-. Everybody follow what we're doing? Don't get lost here. If you've looked at the homework, there is a major problem on the homework. We're going to do a worksheet in class, and I promise you a similar problem on the third exam. So this stuff is really important. Did everybody see why this gives us this genotype? Using the same kind of symbols that we did in Drosophila or peas. And the question is, then, what is the phenotype? So the possibilities for the phenotype are wild type, constitutive, or negative. So wild type means exactly that. When you add lactose, you turn it on. Constitutive means it's on all the time, even without adding lactose. Negative means it's dead and you cannot use lactose. So the question now for this first problem, what is the phenotype of that heterozygote? So take a minute, look at it, see how it works, and then we'll vote on one of the 3 options and see how you do.
Hey, Jen. What's his name? Can you move it a little bit to your left? Thank you. There we go. Thomas.
No, do this by yourselves. Do this by yourselves. And we'll see how well you do. And then we'll see if we need to have a discussion. Is everybody ready to vote? You need more time? Okay, so let's vote. This is not a democracy. Everybody has to make a commitment. How many think that this heterozygote will be wild type? Raise your hands. How many think it's going to be constitutive? Raise your hands. How many think it's going to be negative? Okay, wild type wins. The reason it's wild type is even with that gone, this makes a protein. The I gene makes a protein that can go anywhere in the cell, and so this I gene can work on both of those operators. Now, those who voted otherwise, do you understand why this phenotype is wild type?
So essentially, the I from the one on the left will compensate for
Right.
the lack of.
So because it makes a diffusible protein, it can go anywhere in the cell. That's exactly right. So for those who voted for constitutive or negative, do you understand why it looks like this? Remember, big point question on the homework, big point question on the 3rd exam. All right, let's do a second one. Why would we do that? Because that's the only way to make a diploid. So the reason we're using the F factors is so we can have a diploid. That's the only reason. It's convenient and easy. So that settles this. So is I minus recessive or dominant? Recessive. Number 2. F prime, Pi, POZ, Pi, PO minus Z. And so number 2, we're making the operator heterozygote. We have the same 3 choices: wild type, constitutive, or negative. Do this by yourselves, and then we'll vote. You need more time? How many vote wild type for construct number 2? Raise your hand. How many vote constitutive for number 2? How many vote negative? That's very good. Now let's see why it is constitutive. The O minus means that that's always on. Doesn't matter that you have a good copy on the other side. O minus means that this is always on, which means that this heterozygote has a constitutive phenotype. Again, everybody who voted for wild type or negative, you understand why this is constitutive. Does anybody have a question? There were a couple of hands up.
Yeah, I was going to say, so that basically overrides normal.
Overrides isn't exactly how I put it. I mean, it's on, and so the phenotype definitely overrides. So it doesn't matter if that's blind.
Yeah.
That's just always on. Yes?
Can you explain why?
Because this is an independent unit. We have 4 independent units. I mean, 1, 2, 3, and 4. Those are independent units. Each one has its own promoter. And so what's happening over here is totally independent of what's on the other side. So the fact that that has an operator, no operator, means that that's on. It doesn't matter what the rest is doing.
So O minus means not blocking it.
No, O minus, so the DNA sequence is different, and it means that the regulator protein that can bind there, so this binds there, but it can't bind there because the protein can't leave the new DNA sequence, the mutant DNA sequence. Don't get lost now. There are a lot of points up for grabs here.
I guess what I'm confused with is why the I can affect the O, but the O isn't affecting the E.
So the reason for that is the I unit makes a diffusible protein. So it can go anywhere in the cell. O doesn't make anything. It's a DNA sequence that can't, it's not mobile. So we're looking at the function of these elements in regulation.
I was just wondering why when you draw these in like the abbreviated version, you're not writing the terminating region in, just the promoter.
Because
Just
the elements I'm leading out play no role in the point I'm trying to make.
If it was a different type of regulation for the O, would it be wild type then?
Say that again?
If it wasn't, if the O regulation was different, would it be wild type instead of constitutive or no?
I still don't understand what you're asking.
Think of that.
If you change the sequence of O, the mutation changes the DNA sequence such that the regulator, the LAC repressor, can't recognize it, then you can never shut off the operon.
If it was like a positive regulation
Like an
instead of a negative regulation.
If it's so we have to talk about that. That's a really important point. So this is for negative regulation. For positive regulation, you're going to see, in essence, mirror image like this.
Right.
But we will talk about it. That is an important point. Anybody else?
Let's see.
Okay, so this is constitutive. Let's do the same thing for negative. So let's take this operon. What mutations can you envision that would knock out that operon so it cannot use lactose? How can you mutate this system so that it cannot use lactose? P minus. Another one. There is a second mutation in there. If you mutate that element, you cannot use lactose as a sole carbon source.
Z minus?
Z minus. If you knock out that gene, that's the gene that breaks down lactose to feed into the machinery to make ATP. You can actually, look, I told you, AIM has nothing to do with this, but we can see. Y is the permease, but you can still get enough lactose in through other pumps. That's just a major pump. But you cannot use lactose in a Z minus mutant. So here we have, again, two different mutants. So let's do P minus first. We have P I P O Z. P I P O Z. P minus O and Z. So number 3 is P plus P minus. So the heterozygote, again, P plus P minus. Again, we have 3 choices, wild type, constitutive. Oh, before we do that, what's O minus? Is O minus a dominant or recessive?
Dominant.
Okay. But, yeah. What's the phenotype of that heterozygote?
Negative?
Ready to vote? How many think the phenotype of number 3 is wild type? Raise your hands. How many think it's constitutive? Raise your hands. How many think it's negative? Raise your hands. Okay, wild type wins. So far you guys are doing good. Let's see why. So that promoter knocks out that whole unit. But we still have that unit on the left side. So it works just fine. We don't need 2. E. coli normally doesn't have 2 anyway.
That's not a head count.
I'm sorry?
Number 3 is not a head count.
Yes, yes. The few people who voted differently, you see why the phenotype of the heterozygote promoter is wild type. So let's look at the second one, Z minus. Now we have Z minus. Again, what is the phenotype of this heterozygote? Wild type, constitutive, or negative? Everybody ready to vote? How many vote wild type? Raise your hand. How many vote constitutive? How many vote? How many vote negative? Raise your hands. Okay, very good. So, is P minus dominant or recessive? Is Z minus dominant or recessive? Let's do one more. And we're going to make a compound one between number 2 and number 4. So we have F prime, P I, P O, Z. And in the cell, P I, P O minus, Z minus. And so the genotype here is O minus, Z minus. And now the question is, what is the phenotype? Wild type, constitutive, or negative? We have a compound mutant.
goes on doing nothing. Bless you.
You want more time, or you ready to vote?
Yes.
Okay.
Let's do this.
How many vote wild type for this? Raise your hands. How many vote constitutive? Raise your hands. How many vote negative? Okay, you seem to have a bigger split. Why don't you find someone who disagrees with you and verbally fight it out?
I mean, it'd be doing the wild type stuff, but technically.
No, she's talking about the other one. The regular one that has no meat.
Oh yeah, that one's fine. I don't know. I'm gonna go with wild type because that's what it shows. That's the phenotype. The genotype is specific. The phenotype would be wild type. Negative would negative definitely knock out. Negative, you'd have to take out like the T minus from both sides. Yeah, it'd have to be
Right. Or if you take out the Z
it'd have
from
to be
both.
homozygous.
Or if you take out the Z from both.
Yeah, that would take one. But it has to be from both sides. It has to be homozygous. Wild type phenotype.
But what it shows.
Yeah. Probably take two.
You know, that's my secret weapon against you. I think the first time I did it was like the most beautiful. Like, the most like choreographed.
Yeah, like this whole like 7 routine.
All right,
It was
the
totally
question is, for this heterozygote, double heterozygote, how many vote wild type? Raise your hands. How many vote constitutive? How many vote negative?
Now I'm gonna go make me some pancake house girls.
As we agreed earlier, that O minus is going to make this
Then they'll make me waffles in the morning.
always on.
I don't like pancakes.
It's a pain, though.
So what? It's got a dead Z. Dead enzymes can't do anything. So even though that's always on, it
Bless
is
you.
not constitutive for beta-galactosidase, which means that the phenotype is coming out of the left side, and the phenotype is wild type. It means, in essence, that I lied to you here. That is not dominant. It's called cis dominant. What? Let me explain what that means. This is really important. A lot of points riding on it. If this O minus was truly dominant, it should be able to run the other side. But it can't, because it's just a small DNA binding sequence. This O minus only makes the transcription unit that is in constitutive. It can't go over here and make the other one constitutive. So it is dominant, kind of, but it's called cis because it only works in cis. That means on the same chromosome. It can't work in trans on the other chromosome. So the general rule of thumb is that proteins, like the lactopressor, can work on either chromosome because the protein is diffusible. But DNA sequence elements, like promoters and like operators, they are not mobile. They can't move around. And so this is dominant, but it's a flavor of dominant called cis-dominant. Does everybody see that distinction? Because the operator can't go on and affect the other side. Any questions on this? Yes?
Would I minus then be trans-recessive, or does it not matter?
Right, so, but we don't call it, it's just recessive. But yes, it is actually trans-recessive. It can go on either side if it were good, a wild type, like number 1. Any other questions? All right, now take out the handout from today. This is the last operand. But we're going to turn this into a generalized operand of the form promoter, operator, A, B. So it doesn't matter what A and B does. They're just two genes in a transcription unit. And we're going to have it set up the same way. We're going to have an F prime, and we're going to make all different kinds of heterozygotes. So, again, if you looked on the homework, you saw a very foreign kind of a problem. What we are going to go over now is how to solve these problems. They're called partial diploids. And so this is going to work for the homework that you have and for a major point question on the exam the Friday after Thanksgiving. So this handout is a sheet that tells you exactly how to solve the problem. If you follow this sheet in order, step by step by step, then these problems become almost trivially simple. So, what do I have on that top end? First thing you have to understand is for all of these problems, every time that there's a promoter, that's an independent transcription unit. So for this problem that we're doing here, the same thing. We have 1, and 2. We have 2 separate transcription units. I should put the regulator gene in. And now we can get 4. So we have 4 transcription units. Each one is independent of the other one. That's really important. Remember, each transcription unit is completely independent. So, if we have a promoter minus mutant, we've already done that. Anytime we have a promoter minus mutant, you just cross out. Let's do it in red. You just cross out that transcription unit. So as you go through these problems that we're going to do, that's the first thing you want to look at. That's the easiest thing to look at. You just get rid of all dead transcription units. Any questions on that? Yes?
So R is the regulator.
R is the regulator. So this is generic, right? A, B are structural genes. R is the regulator gene.
With, I assume that would produce a repressor.
Well, so that's question, that's number 2 on the handout.
Oh, sorry.
So you have to then determine, and you will be told, whether the system is positive or negative. We did this earlier in the week, and you had a question on that. If we have a negatively regulated system like LAC, and you knock out the regulator, it's constitutive. But if you have a positively regulated system like CRP, and you knock out the regulator, you cannot turn it on. So you will be told in all the problems on the homework and on the exam whether the system you are looking at is under negative or positive control. And it works differently for those two. Number 3 is to examine the R gene. If it's negative control, that makes it constitutive. It's always on. But that's a really huge but. All you need is one regulator. So a heterozygous regulator is still wild type because R makes a diffusible product. Half the people who get these problems wrong forget that little but in there. So circle it if you have red highlighted. If it's positive control and you lose the regulator, you can't turn it on unless it's heterozygote. So as long as there is a good R plus, in both cases it's wild type. But remember, R minus in a negative system, complete R minus makes it constitutive. Complete R minus in a positive system makes it impossible to turn on. Any questions on that? Now examine the operator. If it's negative control, it's always on. You just did that, and most of you got it right. But O minus in a positive system means the positive regulator cannot bind. O minus in a positive system makes that transcription unit dead. The question will always ask, what is the phenotype of the cell? And so there's going to be a dominance hierarchy. You have two, you'll always have 2 sets, one on the F and one on the chromosome. If the A gene on one is constitutive and the other is wild type, constitutive takes precedence, is dominant to wild type. Wild type is dominant to dead. But remember, R minus, R plus heterozygotes are still wild type. Now the way that all these problems on the homework and on the exam is set up is there's going to be A and B. And so just because A is dead, B is still good. So there are 2 answers for each problem. There'll be an A answer and a B answer. And you have to do each, you have to do A separately, then go back and do B. Any questions on the setup? Yes?
So the A and B answers, what is the AC A plus A, and then constitutive B answer?
No, so you would go through and look at this.
Okay.
Okay, so that's dead, so what? You got a good R there. That can go over here and regulate. So the answer here is going to be minus and wild type. You have to look. So this is what you have to do. Knock out dead units R is always diffusible, and so R goes to both. A is dead, but this is wild type, and so because that's wild type, that makes that plus. If you have to do the same thing for B, you have to analyze A and B separately. Does everybody see that? I have minus up here, it's supposed to be plus, because you have a good one there.
So you don't get different answer A's on both, they make negative on both sides?
Yes, so, and so that's what these problems are gonna have. They're gonna have multiple minuses.
Would that one have a positive B instead of?
But this whole thing is dead, and so it's gonna be, now it's gonna be A minus
Positive, right?
and B plus, because that's still good. That's how you have to analyze these.
Where it says negative control and no minus, which constitutive, if it's heterozygote, would that be alpha?
Depends on which one is constitutive. And so O constitutive overrides I minus. I is recessive, O is cis dominant. But then it depends on the gene, on the allele inside that transcription universe. Yes,
If you had
louder.
in Unit 2, if your promoter was working and not dead, and your O was negative, the system would be constitutive?
So you want to make this wild type?
Yeah, that one's working. Yep.
Yes. And A is constitutive and B is constitutive.
Would we just write a C then for A and B, or?
Right. Constitutive is dominant for wild type.
Bless you, bless you,
Wild
bless you.
type is dominant for minus. Anybody else? Yeah.
Before we had promoter on 2 mutated, is it still possible for transcription to happen without?
No.
So then it would have been negative.
Yes. With this, that's right. That's that.
Oh, I see, sorry.
Yeah. It's getting messy up here. Yes.
So if you had that same situation on the left, but a negative regulator under space 1,
Yes.
would that prevent, would that make A and B negative?
Say that again.
I guess you put R minus in number 1 first.
Well, so now that's minus and that's minus.
Yeah.
Okay. So that's minus, that's constitutive, but there's no R, so that's constitutive. Let's do the problem because I don't want to run out of time, and I really want you to do this problem. So again, this is a cooperative learning exercise.
I think the show just sold out. I don't know. Well, the online sold out. But I don't know. Usually, they let you.
Wear a wig. Some socks in.
I just say work the paper.
Okay.
It's gotten me in before. Even though I don't write about news reviews, I don't write about reviews about anything. But they don't know. They don't read. Nobody
You could
reads.
review some articles.
I could just bitch about people.
You could just bitch about some articles. I don't believe these people talking about their evolution.
That's usually what people say about me.
I don't believe it.
I'm the science writer for the opinion page.
How many people do you get seriously saying, I don't believe it? Yo.
It really depends on how popular the column was. Like, I've never gotten a negative, like,
We've seen like
comment.
raging news threads. It's like shows people on Facebook just like I'm in high school now and these people are trying to teach me about evolution. That's so stupid. I'm not made of a monkey. It's like
Did you guys get some?
it's like don't put monkeys in the zoo because they might evolve.
See, that's the nice thing about working at a university paper, is you really don't get as many people like that. I mean, it's really weird because sometimes we'll get people that don't go to the school that read the paper, and those are the people that send emails more often.
Like the guy who's sitting out there going like,
I mean, I get a lot of people that are like that, but they're usually really
they're respectful because they're writing it.
Well, no, because everyone else gets really mean. I think it's just because, like, to be honest, I'm a better writer than most of the other columnists there. So it's like if you're a shitty writer, it's real easy to get people to be like, well, fuck you, I hate you. And if I'm not a good writer, at least I'm reasonable.
Oh, sorry. That's true. Cellular phenotype for B and I. So, that was the first one. We got a negative promoter over here.
It's not really.
Is that a negative?
What's up?
Is that a negative or just a weird looking R?
That is a negative for the promoter.
Okay.
Let me add one thing.
Oh, shit.
This problem set does say explain your answer briefly. That means annotating it like I did. Cross out the dead stuff and put always on under the constitutive stuff. On the homework and on the exam, if you give correct answers with no annotation, you get no credit. I assume that you just guessed. You've got to do.
Pretty good though. You guys
You've
that.
got to cross out.
I want to know
You've
no
got
prize.
to show always on for constitutive units. You must do that.
I would get so pissed off. I was just sitting there like, I'm just crossing it out.
Well, just pretty much like I have.
Municipal Jake is gonna fuck you.
Or should we got a working regulator over here?
Dude, if that show sold out though, I'm gonna cry.
You should.
Or I'll just like literally just mosh my way in. Just like start from the car into the doorway, windmill in it. Knocking boots.
This don't do shit, this don't do shit, I don't care about that.
So it's always on. You don't have the sound.
You're not answering. Can you tell me this whole bottom one?
You were right.
Just the side, is it P or negative?
That's just a random thing.
Okay, and then it's POA minus B? Okay,
Is that it?
that's all. Thank you.
Next time I just keep going.
Okay, so the main difference regulator.
So I's working. We got a constitutive
It's
A.
when you can't tell the difference between things because the it's kind of fucked up.
A is C. And we got working B.
That's like
So,
looks like an eye.
so right.
It's not that thing on the bottom.
Yeah.
You should have to type in there.
So the regulator.
So the bottom one reads P R minus
So he gets 0 points.
P O
right?
A minus. Yeah, he would
But this side.
He gets $0.
0. Do not cast go. Do not class whatever.
Look at this.
How much are those shells?
Wild card on one side. Always on.
I like how it's standing up on its own, like some type of demon
I'm pretty
magic.
freaking amazed.
What type of dirty ritual did you do to get that?
So what's knocked out?
You do dirty rituals to get things that you do.
Some horrible monster ritual.
You a witch?
I think half the people I meet are witches,
Pretty sure half the people I meet are witches.
especially in math. You ever had a teacher call it black magic when they just somehow randomly get the answer and they don't know how?
No, you're using.
It's always in a class that allows calculators, so.
I think my favorite column that I got to write, I wrote about how I don't understand how computers work, right? And then I said, I described it as my best guess as to how they work is like the vile sorcery of hobgoblins.
I like it.
I was like super certain that my editor wouldn't publish it, and then that was like the only. She didn't edit it. Like I was like, Jacob Happy.
You're like, yeah.
I mean, what is
gotta get down on the five.
Yes, it is. P R minus P O or P O A minus B. That thing is not supposed to be.
So he gets $0.
For that side. What about this?
It's supposed to be a normal.
Yeah, O is fine. It's A negative and R negative. Okay. Okay.
Or if it's dead. Like there was no Z in the first one, then that's probably.
So the R.
But it's up there.
So if you have like a negative in one of them, it's not.
Yeah. I don't know who's on whose side now.
Oh, like either of you.
It's transcribed, but it's not.
Yeah, it's, you say that there's, no, it's not like.
I just crossed off.
I think the X just means it's not transcribed.
So like, so say it's still gonna like you see that they give like an R minus, but not a P minus. It's gonna transcribe R, but it's going to transcribe an R.
You could choose from.
Like it's,
I mean, technically the whole translation you
top down. Top it in. This is like what I heard. Can you tell us if this is right? Constitutive positive, negative positive, constitutive positive, negative. No, which one? Are the two bottom ones?
That one's wrong.
Just
Yeah, it's just A. B is fine.
Yeah, but it's important, I guess. It's already saying it.
So should we put one type or should we put plus? It doesn't matter.
It doesn't matter either one.
So either one would be right. No, you can take it off the board. Either one can be fine on homework. Talk to him about it. Okay. I would think it would be fine. Okay.
so.
And what does this last one say? Is that I in there?
No,
Yeah,
no.
ignore the I.
Oh.
That's like a typo that's never been fixed.
Okay.
Yeah.
So for this one, we have no negative means it's constitutive.
In a negative regulation system. But this
Oh, it's
is not
positive.
negative.
I didn't see that. All right, thank you.
Okay.
You only need one good P.
Yeah.
So it's positive.
Yes.
Make sure you're reading. Make sure you're reading.
Oh wait, never mind.
Just try reading.
Yeah, exactly.
That's not a word. That's a symbol.
What? 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 Thank you, by the way, for. What's up? Thank you for. Oh, no. I don't know his name. I'm just gonna call him.
Man who moved to left.
Pro side and got him to left.
Sinestro.
Alright. So, you look if it's a negative or positive. That's what I did for all wrong. But go around to each single piece. So look for any P negative. If it's P negative, just cross the whole thing out, doesn't matter. And then look around and say what each thing will do. So in like an R, if you have an R still working, put a positive, that means it's still going to be doing its own regulation. And just do it like that, and then you'll just, whatever's left over is what you get. And then make sure you're reading negative or positive. Because if you have an O constituent in a positive system, it's not doing anything. Because so for negative systems, you put the regulator on to turn it off. In a positive system, you put the regulator on to turn it on.
Solution for walk exercise will go up with the notes that are posted out this afternoon. Make sure you know how to do this.
Which one? The third one? Yeah, positive.
Big exam problem that happens.
Was that it?
Rowdy.
All right, 95,000, yo.